Hi, welcome. Andy's here. It's lesson 3, maximum and minimum principle. Ready to solve some problems? Here we go. A shop sells sweets where every 3 sweet wrappers can be exchanged for 1 more sweet. Sharon has enough money to buy only 11 sweets. What is the biggest number of sweets that she can get from the shop? So we are trying to find the maximum value. How do you solve this problem? We can use a method of drawing a diagram. Here we go. First, let's have 11 candies. Here we go. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's finish all the candies. And then we can use the wrappers, sweet wrappers, and exchange the wrappers for more sweets. So 3 wrappers for 1 sweet. Here we go. We have 1. Try to have a square here. And then another 3 wrappers. We have another one more sweet. Then we have another 3 sweet wrappers. Exchange for 1 more sweet. And we finished them all. And we notice that we have 3 more wrappers. So we can use those 3 sweet wrappers and exchange for 1 sweet. So we put it here. Is it over? Not yet. Don't forget, there were 2 more sweet wrappers. So we have those 2 and 1 sweet wrappers. And together, we can exchange for 1 more sweet. So now you can count how many sweets are there in total. 11 and then 12, 13, and 14. And then we have 1 more. And then lastly, 1 more. So we can use a mathematical equation to represent. Here we go. Have it here. First, 11 and plus 3, and then plus this one, and then here's another one. We get 11 plus 5, so in the end we have 16. Well done if you got the same value. So the maximum value is 16. And the biggest number of sweets that she can get from the shop is 16. Alright, so next time you can draw a diagram and to find the maximum value. Alright, so this is how we solve this problem. Next, what is the least number of cuts required to cut 16 identical sausages so that they can be shared equally among 24 people? Okay, so you are asked to find the minimum value. How do you solve this problem? So first, you notice that we have 16 sausages. They're identical, and they are equally shared by 24 people. So first, we know the fraction of sausage for each person is 16 divided by 24. So we have here 16 divided by 24. We try to use the simplest fraction to express it. So we have 2/3. So each person will have 2/3 of the sausages. That means no one gets one whole sausage. So we know that at least there will be 16 cuts. And then let's cut the sausage. We can use one sausage to represent the whole sausage because they are identical. So here we go. We draw a sausage here. And we split it into 3 parts because we need to cut it at the 2/3 mark. Here we go. 1, 2. Let's cut it here. 2/3 mark. And then, because we have 16 sausages, so we have 16 2/3 of sausages after the cut. Here we go. 16 times 2/3. And we also have this part. 16 1/3 of sausages. Here we go. 16 units of 1/3 of sausages. Now we have 24 people, and we know that each person has 2/3 of the sausage. So we have 16 units of 2/3. That means we can give it to 16 people. And then how are we gonna do with the 16 units of 1/3 of sausages? So we notice that 16 times 1/3 is 8 times 2/3. So each person needs to have 2/3 of sausage. So that means we can actually give 16 units of 1/3 of sausages to 8 people. Here we go. And we notice that 16 plus 8 is 24. So 24 people. That means we are correct. So we need to cut, the least number of cuts will be 16. All right. Congratulations if you got the same value. So next time, when you try to solve this kind of problem called maximum and minimum principle, you probably need to first understand the question, find very useful information, and then maybe try to use a diagram, try to draw a diagram, and to find the final value. So that's how you solve this kind of problems. All right, I think it's time to say goodbye. All right, so this lesson is about maximum and minimum principle. So when you try to solve this kind of problem, maybe try to use a diagram, to try to draw a diagram to solve it. Thanks for watching. I can't wait to see you next time. Bye.